So, hi guys, how are you all? I hope all of you are doing good. And I just want to know how is the quality of the broadcast. That is, you can see me and hear me properly as well. You can rate it from 1 to 10. There's 1 for the worst and 10 for the best. So, how are you all? And I hope you are studying well. I'm waiting for you guys to join. Today, we are going to study an important chapter, that is electrochemistry, guys. So, how is the quality of the broadcast, guys? Let's wait for some viewers. Let's wait for some students. And then we will move on. Right, guys? So I just want to ask, how is your preparation going on? So. Okay, guys. Let some other people join. Let some people join. We are live again with another topic which is very, very important. That is electrochemistry part 2. We have studied electrochemistry part 1, in which we studied about different cell equations, what is a Daniell cell, what is uh, the half cell reactions, electrode potential, cell potential, everything we have studied. We're going to revise it once and then we're going to move on. So I just want to know how is the quality of the broadcast, that is, you can see me and hear me properly as well, right guys? So okay, and without wasting much of the time, let us move on. So my name is Khushang Dhingra and I am a graduate from Delhi Technological University. I have completed my graduation from Electronics and Communication Engineering, that is ECE there. I recently have been passed out from my college and I secured 99 percentile in my JEE Mains. Right, guys? So I hope all of you already know me, and now we're gonna move on and we're gonna switch to our current topic which we're gonna study today. Before that, I just wanna ask you, how is your preparation going on? JEE Mains is really near, guys. So I hope you are watching our videos which we are making specially for you, for that, so that your preparation level may get increased, right? Okay, guys. So today we're going to study electrochemistry part 2. Right. So that is it, guys. Now we're going to we're going to start the chapter. Before that, I just want to know, none of you have commented down that is the quality of the broadcast, that is, you can see me properly, you can hear me properly. I just want to know so that we can move forward, because without knowing that, I'll be just talking and talking with you guys, and you guys maybe you guys can't hear me, or maybe you guys can't see me properly. So please just rate the quality of the broadcast. And one more thing, I just want to know that how is your preparation going on. You can rate it on the scale of 1 to 10. Oh, sorry, 1 to 3. 1, 2, and 3 level. Right, guys? So you can rate it here. That is 1 for not a very good preparation or bad preparation. Second is for not so good, not so, or you can say good preparation. That is, you are such confident that yes, I can secure at least 150 to 200 marks in J. And level 3 is you are at a very good or best level of preparation. You are giving your best and you gonna score at least above 200 marks in your coming JEE Mains exam. Right, guys? So I just want to know that, and then we can move forward. That is 8. That is 8. Okay. Right. Okay, we'll move on. And first of all, I just want to ask, and I just want to make a small request, that please subscribe to this channel where we provide you free classes regularly. Like, we are having right now, and we just provide you at least 2 classes of each subject every week, right? So 2 classes of each subject every week. We're gonna have these free classes at YouTube live, and you can just join these classes and revise, because I have told you in JEE Mains, the one who wins is one who revises, not who just completes the syllabus, right? So we're gonna write the same thing and we're gonna start our lecture on this note. Completing the syllabus. Right guys, so the one who revises wins, right guys? So now we're gonna move on to the topic, that is, the topic is Nernst equation. So before moving on to directly to the Nernst equation, let us revise what we just did in the previous class of electrochemistry. What we did is we just came to know that these all the cells reactions are due to the redox reactions happening inside the cell. Redox reactions in the cells, right guys? So what is the redox reactions? The reactions in which oxidation and reduction happens simultaneously. Right guys, so oxidation and reduction happen simultaneously in a reaction. That these types of reactions are known as redox reactions, right? Now what were the uses of these redox reactions? Actually, what is reduction and oxidation? One second. Reduction, what is the cause of reduction? Reduction is gaining of electrons. And what is oxidation? Oxidation is losing of electrons, right? So one element loses the electron and other element gains the electron. For example, Zn2 plus, Zn becomes Zn2 plus by losing 2 electrons, and these 2 electrons are caught by Cu2 negative, or you can say Cu exists as Cu2 positive, and this just gains 2 electrons and becomes stable, completes its octet, right? So when we studied about these reactions, that is Zn giving out Zn2 positive plus 2 electrons, and Cu2 plus gaining 2 electrons to form Cu metal, right? Cu solid or Zn solid here. Then we came to know that these two reactions are used by Daniel to form Daniel cell. Daniel to form Daniel cell, right guys? What was the Daniel cell? Let us just revise that. What was the Daniel cell? Actually, we took two containers. First container, second container. Here in this container we put a solution, that is CuSO4, that is copper sulfate solution in this container, right? Then what we did, in the other container we put a solution, that is zinc sulfate, that is ZnSO4. Now we put a copper metal rod in the copper sulfate solution. One second. Okay. See, one rod that is of copper. In fact, we can just switch this. Okay, here Zn and here Cu. Okay, now this is a zinc rod. In ZnSO4 solution, we dissolved or we put in a zinc metal rod, and in the CuSO4 solution we put in a copper rod, copper metals rod in it. Right, and then what do we do? Now? We just connected these two rods with a wire. Right guys, here you can see if this is a ZnSO4 solution, so it has two types of ions, that is Zn2 plus ions and SO4 2 minus ions in it. And here in CuSO4 we have two types of ions, Cu2 plus ions and SO4 2 minus ions in it. Right, so we already know that between zinc and copper, zinc is a more reactive element, where we saw that in the metal activity series, which is given in your NCERT, metal activity series, which is given in your NCERT, what it implies that the metals which lie above some other metals are more reactive to it, and the above metals will lose electrons, will get oxidized, and the lower metals will gain the electrons and get reduced. So in between zinc and copper, zinc will get oxidized and copper will get reduced. It is not compulsory that between zinc and copper only it is not compulsory that copper will always get reduced and gain electrons always, but no, as for example between Ag, that is silver, and copper, the copper will be the one getting oxidized and silver will be the one getting reduced, because copper is more reactive than zinc. Where we get to know that? We get to know it from the metal activity series, which is given in your NCERT. That proves all of this. Right guys? So now we're gonna move back to our Daniell cell. Right. So in the Daniell cell, here we know that zinc 2 positive will be more stable than copper 2 positive. Copper will be in a tendency to gain 2 electrons from zinc. So here you can see there is a zinc rod and the zinc atoms are there in it. So what is more stable, zinc or zinc 2 positive? Obviously zinc 2 positive is more stable, as it just completes the octet. So what will happen actually is this zinc atoms will start losing 2 electrons and start getting dissolved in the solution as Zn2 positive, plus 2 electrons they will lose. These electrons will flow in this wire. Now here you can see that Cu2 positive ions are in the solution. Obviously between Cu2 positive and Cu is more stable. Right, so copper will have a tendency to gain 2 electrons. So when it will see that yes, electrons are coming from the wire on the rod, the ions in the solution, that is in the CuSO4 solution, will start getting deposited on this rod and start gaining 2 electrons to form copper metal. Right, what will actually happen is Cu2 plus ions will gain 2 electrons to form copper metal, and copper metal rod will get thicker and thicker. Similarly, the zinc metal rod will get thinner and thinner as zinc metal or the zinc metal ions are getting dissolved in the solution and electrons are getting flowed, right? One second, guys. Okay, moving on. Okay, so we'll move on. So now we conclude that electrons started getting flowed from this container to this container, and due to the flow of electron, what is generated? Electricity. Electricity is generated due to this flow of electron, and now Daniel was successful in creating a cell, in converting the chemical energy to electrical energy. I hope all of you guys got it. So now what one problem arose, you can say. What was that? After some time, see, how do Daniel checked that yes, electrons are flowing in it? What he did, he just connected one bulb with this, you can say, with this wire, connected one bulb, and the bulb started glowing. So he was very much, you can say, confident and happy that yes, I have converted the chemical energy into the electrical energy. Now what to do? Now actually he created a setup and he said that let me use the washroom once, and he went to washroom, and when he came back the bulb stopped glowing. Why? The question arose, why? Many students will say that zinc rod was getting thinner and thinner, so zinc rod must have been depleted completely, and copper rod was getting thicker and thicker, all the copper ions must have been vanished. But no, actually it was not the case. Let us draw the cell once again and then we will discuss. Let me take a very open space. So actually what was happening is, see, one container, second container. In this container zinc rod was there, in this container copper rod was there. What was actually happening? The electrons were flowed from this to this here, right? So actually what was happening is that copper 2 or zinc 2 positive ions were getting deposited here. So positive charge was increasing here to a very large extent, and here you can see Cu2 plus ions were getting deposited on the rod. So obviously SO4 2 minus ions concentration will be getting increased. So negative charge was increased very much in this container, and the electrons contain a negative charge. So electrons, when the electrons were coming here, they were getting repelled by this negative charge. We can write here repulsion due to negative charge, right? And here you can say what is happening, attraction. Why? Positive charges are attracting the electrons due to positive charge, right guys? So this was the reason, and one more thing was there, that the circuit was not complete. Was not complete. Actually, when we draw a circuit, we draw a resistance here, we draw a voltmeter here, and we connect a battery with it. So the circuit gets completed. But here you can see 1, 2 and 3. Only this is there. Where is this part? There is no circuit completion. So now Daniel was devastated that what to do now. So he found out a solution that was known as salt bridge. He found a solution known as salt bridge. What was the salt bridge? It was made up of a substance known as agar, which included KCl in it too. KCl. So K plus and positive Cl minus. So actually what happened is there were two containers. Let me draw it once again with a great drawing which I don't have right now. Okay. So this was having a solution. This was also having a solution. There was a metal rod in it. There was a metal rod here, a metal rod here too, and what was happening? There was a wire connecting them, and that's it. So now what he did, he made a salt bridge. What was the salt bridge? One second. Okay. Salt bridge did this. There is one salt bridge and it was connected like this. And this salt bridge contains what? Agar in it. What was agar? KCl. So what did these things, what did this agar do? Actually it contains KCl. Firstly, it completed the circuit. Completed the circuit. Right. Second thing what he did was, that it just what did here, positive charge was getting excessive and here negative charge was getting excessive. Now K plus and Cl minus both have positives and negative charges. So Cl minus just got here and neutralized this positive charge, and K positive came here and neutralizes this negative charge. Now electrons started flowing again. And bulb started glowing again. Bulb started glowing. So this was the complete funda of Daniel cell. Now what we did was we just introduced how to write a cell in the equation, in equations form, cell. Then we discussed about electrode potential. What was electrode potential? Yes. What was this? This was zinc. This was copper. This was getting oxidized. And this was getting reduced. So the one who getting reduced is known as cathode. And the one getting oxidized is known as anode. Right? Okay, guys. So now we discussed about electrode potential. Okay. So the electrode potential was, for example, see here that there was this zinc electrode and there was this solution in it. This solution ZnSO4 is known as electrolyte, and this rod is known as electrode. So the potential difference between electrode and electrolyte is known as electrode potential. Let us just write it. Potential difference between electrode and electrolyte, electrode and electrolyte is known as what? Electrode potential, electrode potential, right? Then we just came to know that cathode has a positive potential with respect to what? The electrolyte. And anode has a negative potential with respect to electrolyte, right guys? Now what we have to do is that yes, there are two types of potentials. There are two types of electrode potential or the standard electrode potential. What is standard electrode potential? Standard let us take another page. What is standard electrode potential? Electrode potential when the concentration of the electrolyte or the species involved is unity. Concentration of species involved is unity. This is known as standard electrode potential, right? Now what to do? Now there are two types of standard electrode potentials, that is standard oxidation potential and standard reduction potential, right guys? So how this is denoted? This is denoted by E naught for the standard, and oxidation is happening, so M will be converted to Mn plus. Sorry. And this standard reduction potential, E naught for standard electrode potential, then Mn plus will be getting converted to M, that is reduction will be happening here. So this was the case. Now this representation of cell. I'm sorry guys. Okay, representation of galvanic cell. Okay guys, so here you can see how it is represented. Firstly, anode is written, that is Zn will be converted to Zn2 positive, then a double bar for the change of electrode, then Cu2 positive will be getting converted to Cu. Here aqueous will be written, here solid will be written, here solid will be written, here aqueous will be written. So this is the case for the representation. For example, if there is a Cu and Ag's cell, how to represent that cell? That in that cell Ag will be getting converted to Ag2 positive and Cu will be getting converted to Cu2 minus, or you can say Cu. So here a Cu will be getting converted to Cu2 positive and Ag2 positive will be getting converted to Ag. Here solid, here aqueous, and here solid. So this is how we represent the standard electrode potential or representation of cell. Now there comes one more important thing, that is she is not, I'm talking about not not talking about women, but she is what? Standard hydrogen electrode. What is a standard hydrogen electrode? Actually it is used for hydrogen, putting in hydrogen, making a cell with hydrogen, and we came to know that its electrode, that is a standard electrode potential for both oxidation and reduction, is equal to 0. So how can we calculate electrode potentials of a single half cell? We calculate it by using SHE. What we actually do, for example, let us measure the zinc electrode potential. Measurement of zinc electrode potential using SHE. What we actually do, we place SHE here and we connect it with the zinc electrode. Here ZnSO4, here zinc rod, here ZnSO4 solution will be there, and this is a zinc electrode. Now what will we do? We know that of SHE, standard reduction potential will be equal to electrode potential, standard oxidation potential will be equal to 0. Now we know that what is the cell potential? Cell potential is the potential difference between two electrodes of the cell. Between two electrodes of the cell. Right guys? So now E naught cell will be equal to E naught reduction potential of the cathode. What is the cathode? SHE here. Now and what is the cathode? That is zinc. E naught H plus and H2. That is the anode, where we know it is equal to 0. So E naught cell will be equal to E naught Rp of, or E naught of Zn2 positive to Zn. And how to calculate E naught cell? We use it by voltmeter. This is the case. Now we have calculated. Now we will move on to the Nernst equation. What is the Nernst equation? Nernst equation is that till now we calculated all the electrodes potentials or the standard potentials when the concentration was equal to 1. Now Nernst was a scientist who said that we can calculate electrode potentials with any concentration of the species involved. So what is the formula? EMN plus going into EM will be equal to the standard electrode potential of Mn plus to M minus RT by NF ln concentration of M by concentration of Mn plus. So you will be saying, what is this equation? So see, here we want to calculate the potential of electrode. Here this is the standard electrode potential, right? Here we are subtracting RT by sorry, we are subtracting RT by NF. What is R? Universal gas constant. What is T? Temperature. What is N? Number of electrons involved. What is F? Faraday's constant. What is this? Concentration of metal. What is this? Concentration of Mn. So this was given by Nernst, right? So if we apply this Nernst equation for Daniell cell, what will happen? Nernst equation for Daniell cell. What is the Nernst equation for Daniell cell? Actually, we know what is Daniell cell, that is Zn to Zn2 positive double bar Cu2 plus 2 Cu. Right guys? So now if we want to calculate for cathode, what was the cathode? The copper. See, ECU2 plus 2Cu will be equal to E naught Cu2 plus 2Cu minus RT by N. What is N? 2 electrons and 2F into Ln. Now what is will be the concentration of Cu, as it is a solid, so we take the concentration as 1 and the Cu2 positive's concentration. Now similarly calculating for the anode, E Zn to Zn2 positive will be equal to E naught Zn to Zn2 positive minus RT by 2F into 1 by Zn2 positive. Right guys? So now what will happen is we have both equations for anode and cathode. So if we calculate E cell is equal to E cathode minus E anode. That is E naught Cu 2 positive to Cu minus RT by 2F into में 1 by Cu 2 positive. Then minus E naught Zn to Zn2 positive plus RT by 2F Ln 1 by Zn2 positive. So what will be the equation now? What will actually it become? Solving it, we can conclude that E cell using the Nernst equation on Daniell cell the equation becomes what? E cell will be equal to E naught cell minus RT by 2F Ln Zn2 positive divided by Cu2 positive. We can also conclude one thing, that if we generalize this, E cell will be equal to E naught cell minus RT by 2F Ln of anode's concentration divided by cathode's concentration. This is the case. Before moving to the next topic, I just want you guys to subscribe to this channel, guys. As here you can just join the Alt-Me JEE channel, that is Alt JEE. You can scan the QR codes which will lead directly to the Telegram. Here we provide you free PDF materials, free classes. We make announcement of the classes we are gonna having. We make some discounts and prizes there. One thing more is going on, that is a daily challenge question. If you solve the question first, then you will be getting some rewards and some prizes too. So what are you waiting, guys? Please go and join the Telegram channel, that is Alt J, and you can just scan the QR code too. Right guys, now moving on, we know that using the Nernst equation we can find three things. First is the EMF of the cell that we just calculated. Second thing is the equilibrium constant. Third thing is Gibbs energy. So this thing we have already did that. Now next thing is equilibrium constant. So you will be saying that where equilibrium is attained, how we are talking about equilibrium here, where is the equilibrium, how we can talk about equilibrium constant, right? So actually what will happen is after a certain amount of time, The zinc, for example, if we talk about in Zaniel cell, Zn was getting converted to Zn2 positive plus 2 electrons, and Cu was getting converted into Cu2 positive plus 2 electrons, giving out Cu. So at a time there was a reaction that these both attains equilibrium. And when we saw that it attains equilibrium now, so E cell was equal to E naught cell minus RT by 2F ln of, that is what, Zn2 positives concentration divided by Cu2 positives concentration, right? So what will actually happen is, see, if we directly write the equation Zn plus Cu2 positive interconvertible to Zn2 positive plus Cu. So at a time when this reaction will attain equilibrium, then Kc will be equal to Zn2 positive divided by Cu2 positive. So this will be equal to the equilibrium constant. So putting it in this equation, what we get is, in this equation, what we get is E naught cell will be equal to 2.303 divided by NF into log Kc, and this 2.303 by F is equal to 0.059. So E naught cell will be equal to 0.059 divided by N into log Kc, which is a very important reaction for your JEE mains. JEE asks many questions on this topic. So I think we have done much in today's lecture. Now we will move on, and let me just tell you about our course, guys. What is our course all about? Actually, we are having what, uh this is wrong. We will be having 120 plus classes. What we'll be having is 120 plus classes. Each and every subject, each and every topic will be covered. No stone will be unturned in your preparation for your JEE mains, right? And what will be the duration of this course? We will be together until your exam, until your JEE mains, right? We have designed syllabus from JEE experts, where we use a method known as the flipped classroom method. What is the flipped classroom method? Actually, I'll explain you it in the other slide. It is a very, you can say, useful method. Top rated universities use this method. Universities use this method, and many students have increased their marks up to 30% using this flipped classroom method. Now next is doubt solving practice. We'll provide you, the main thing is we'll be providing you one-to-one mentorship, which you will be needing the most right now, as it is the high time for your JEE mains, right? So the theory we'll be providing you theory and study materials before the webinar. Then we will be conducting a webinar. So what will this change? Actually, what we'll be having is, you will be studying the theory and the study materials before the class. When you will study all the things, you will get to know in your hand that yes, this is the thing which I am not getting on my own. Then we will be having webinar. We will be discussing each and everything in detail. So the idea will be crystal clear in your mind that yes, each and everything which I have studied till now is correct, and I can solve n amount of questions on this topic. Now checking that, we'll be providing you some homework which you will be solving on our website, on our platform, where you will be getting the marks and in a particular time duration, which is very important, so that you can get friendly to the exam atmosphere. Now your homework will be getting checked, and you will be getting to know that these are the topics you are lacking in, and you can work on them so that you can improve and you can do that, right? Next thing is, each and every student's requirement is different. One student says that I have just to clear JEE mains, and other student says that I have to do advanced too, right? So we have courses for both of them. If you want to take that, that is the smart course. Here we'll be having interactive live classes, structured courses and PDFs, live tests will be conducting, physical notes, and most important, my favorite thing is, that is the one-to-one mentorship. program. That is, we can connect with you directly. You can ask your doubts about the subjects, about topics, about life, about admissions, about how which branch to choose, each and everything you can do that. Then we'll be having live doubt solving. And one more important thing is mock test. You know, mock tests are really important right now as your exam is coming near. So you will be giving numerous mock tests so that you can track your preparation, that yes, I am at this preparation. Then mock test by mock test you can improve your preparation, you can keep a track on this preparation. If you are solving mock test right now and if you are solving it the right way, that is correct. But if you are not, if you need some guidance on how to solve mock test, then you can check out the video I have made on how to solve mock tests properly in a better way, so that you can increase your marks giving these mock tests. So you can do that, you can just check out that video. And in the additional special courses, we'll be providing you additional courses in the proficient plan, that the students are who are aspiring for JEE advanced, that they can get this, where we'll be providing you each and every topic, advanced study materials, each and everything we'll be providing you. Next is a surprise for you, that for now this 7,990 course we are giving out in 2,990 only. It is a very efficient and a very beneficial plan. It is for the smart plan, right guys? So you can just, what you can do is you can just scan this QR code, which will lead you directly to the bot, which will guide you how to do one-to-one mentorship and how to take the course. So this was it for today guys, so we will meet soon in the next lecture. Till then, bye bye, see you soon.